In this lesson, you will learn how to solve quadratic equations by completing the square. Let's look at example 1. We have x squared plus 8x minus 20. Let's rewrite this with places to add our c value and subtract our c value in order to complete the square. So we have x squared plus 8x plus a blank, that's where we'll put our value that completes the square, minus 20 minus a blank. We have to add a value to complete our square, so that means we're going to subtract that same value in order to keep this equal and balanced. So we need to identify our b value. Our b value is 8. In order to complete the square, you will take half of that value and square it. So half of 8 squared will be our new c value in order to complete the square. Half of 8 is 4. And 4 squared is 16. When we add that and make the trinomial x squared plus 8x plus 16, that completes the square. But then we also need to subtract it in order to keep this equal and balanced. So x squared plus 8x plus 16 is now a perfect square trinomial and can be factored as one quantity squared. So it will be x plus half of your b was 4. Then you'll need to combine the like terms, negative 20 and negative 16, which gives us a negative 36. Once you have completed the square and rewritten your problem from standard form to vertex form, you now just solve by undoing the operations. So let's add 36 to both sides. X plus 4 quantity squared is on the left because negative 36 and positive 36 cancel one another out. And then 0 plus 36 gives us 36. We now need to undo the operation of this exponent. We do that by taking the square root. When you take the square root, always remember to use a plus and minus sign around your values that you're taking the square root. X plus 4 is left on the left side. Plus or minus square root of 36 will equal plus or minus 6. We'll need to subtract 4 in order to solve for x. So x is going to equal, you could say plus or minus 6 minus 4. However, you'll forget sometimes that that is a plus or minus 6. So it's better if you write negative 4 first and then the plus or minus 6. That way you can tell yourself you need to add 6 and you need to subtract 6. So let's do that now. So our x is going to equal negative 4 minus 6, and our x is going to equal negative 4 plus 6. Negative 4 minus 6 is negative 10, and negative 4 plus 6 is 2. So our solutions to this quadratic is negative 10 and positive 2. You could check this with the graphing calculator, so let's see that now. Rewrite the original problem as an equation. Y equals x squared plus 8x minus 20, changing the 0 to a y. So type that into the y equals function of your calculator, x squared plus 8x minus 20. You can hit the graph button to see the graph. If ever it's difficult to see your graph in the full screen, you can adjust it by hitting zoom or even window settings to adjust it to how you need. We can see negative 10, barely, but it does cross there at negative 10, and positive 2. So that's a helpful way to check your answers with the graphing calculator. After doing all this work, take the time to check that corresponding function, type it in by changing the 0 back to a y, and type in your equation. View that function and see that your solutions do match. Let's look at another example to complete the square. For number 2, we have x squared minus 6x minus 40 equals 0. Let's rewrite the equation with blanks in the place for plus a c value and minus a c value that will complete our square. Remember, if you're going to add a value to the equation, you'll need to subtract that same value to keep this problem equal to what it originally started as. Let's find the c value. So we'll take our b, which is negative 6, and take half of that and square it in order to complete the square. Be sure when squaring negative numbers you include parentheses. Negative 3 squared is 9. So that is the value that will complete our square. We're going to add it to make the perfect square trinomial and subtract it to make this equal and balanced to what it originally started. The left-hand side is factorable as x minus 3. X, because it's the factors of x squared, minus 3 because it's half your b, or you can even think it's factors of the 9. It may be better to think of half your b so you get your signs correct. It does need to be on negative 3. So 1 parenthesis squared is our factors for that trinomial. Then you'll combine negative 40 and negative 9. Once you have written this from standard form to vertex form, you're now ready to solve. Let's add 49 to both sides. So we get x minus 3 quantity squared equals 49. Because the negative 49 and positive 49 cancel, 0 plus 49 is 49. We need to undo the exponent squared, so that means we'll need to take the square root. Don't forget the plus or minus sign when taking the square root of 49. So we get x minus 3 equals plus or minus 7. The square root of 49 equals 7. Let's add 3 to both sides to solve for x. X is going to equal 3 plus or minus 7. You will do much better if you write the 3 first before the plus or minus sign. That way here you can tell yourself you need to take 3 minus 7 and 3 plus 7 to find your solutions for x. 3 minus 7 is negative 4, and 3 plus 7 is positive 10. So our solutions are negative 4 and positive 10. Remember, you can check this with the graphing calculator, so go back to y equals, rewrite the equation, x squared minus 6x minus 40, instead of equals 0, we're setting it equal to y, so we can graph it, and see that it does cross at negative 4 and positive 10. Again, you can always change your zoom settings or your window settings to better see that graph. Let's look at one more example. Number 3. We have x squared minus 10x plus 34 equals 0. Let's set up our problem with our blanks. Plus a blank to complete the square, and minus a blank to keep it equal and balanced. Find your b value, which is negative 10. You'll take half of that and square it in order to complete the square. Half of negative 10 is negative 5, and square that to give us a positive 25. Always be sure to square a negative with parentheses so you can correctly get your value. The left-hand side is a perfect square trinomial, and it factors as x minus 5, quantity squared. The last two terms you'll combine 34 minus 25 and find that that equals 9. Now that we're in vertex form, we're ready just to undo the operations. So we need to subtract 9. So our x minus 5 quantity squared equals negative 9. We'll take the square root of both sides. Squaring and square root cancel one another. Don't forget to do plus or minus the square root of the negative 9. So x minus 5 is left on the left side. Plus or minus, the square root of 9 is 3, but we're taking the square root of a negative 9, so that would be 3i. The square root of negative is an imaginary number, so don't forget your I. We need to add 5 to both sides. Again, put that 5 in the front of the plus or minus 3i. This works well for this type of problem because now this is in correct form for a complex number, which is a plus bi. 5 is our real part and 3i is our imaginary part. You can still write these two solutions as 5 minus 3i and 5 plus 3i. We just cannot simplify this any further because those are not like terms. So our solutions are 5 minus 3i and 5 plus 3i. Because we have imaginary solutions, this graph will not touch the x-axis. Let's view that in the graphing calculator. We have x squared minus 10x plus 34. You can barely see it here at the very top of your screen, so you can do zoom out and see that it zooms out and still it does not touch that x-axis. That's why we end up with imaginary solutions. If it touched the x-axis, we would have real solutions. But this graph does not reach that x-axis, so that's how come we come up with imaginary solutions.